Okay, moving on, we got some Richter scale problems. The equation for the Richter scale it looks like this. You can see it in the problem down here. So before we read the problem, the Richter scale equation involves this ratio, which I've highlighted there. Okay, we will never, ever need to know I all by itself, and we will never need to know I sub 0 all by itself. So the way the Richter scale works is scientists go out, they measure what's the smallest possible vibration in the surface of the Earth that we can measure, and they call that I sub 0. It's some certain minimum intensity used for comparison, right? It's only used for comparison purposes. We don't need to know what it is. The only thing we ever use it for is to say, this earthquake was blah, blah, blah times more intense than this comparison value, right? So in the equation, we could really just replace I over I sub 0 with ratio. We could call it X. We could call it whatever we want, right? We're not actually in charge of coming up with the seismological equations. We can't change the Richter scale equation. But for our own personal use, we could rewrite the equation. Really, it's just R equals log of this comparison ratio, right? And we don't need to know what I sub 0 is or I either way, ever. Okay, so here goes. The largest earthquake in a certain year in the ocean. It was in the ocean. It was recorded as an 8.9 on the Richter scale. The most devastating earthquake in a major city that registered 7.4 on the Richter scale. How many times more intense was the quake in the ocean? Okay, well, that's what the letter I is about. It's that ratio of intensity. So in highlighted yellow there, how many times more intense? That's referring to this ratio. So basically, it's just the thing inside the log, inside those parentheses. That's our final answer, right? Okay, so the quake in the ocean was how many times more intense? So we've got to find out. All right, here's the deal. Subtract the numbers on the Richter scale. Find the difference in the Richter scale numbers. That is our first step. 8.9 minus 7.4, that's 1.5. That's the number we're going to put into the equation as R. Okay, so 1.5 equals the log of this ratio, and we don't need to keep track of I and I sub 0, so I'm just going to call it ratio, right? 1.5 equals log of the ratio, or you can call it X. That's our answer. Okay, so all we need to do is get rid of the log, right? Raise everything as a power of 10. 10 to the power of 1.5 equals this ratio, right? 10 to the power of, and the logs, those are inverses and cancel. Calculate 10 to the power of 1.5 on my calculator. It's 31.62. Final answer. Okay, that magnitude 8.9. Okay, the Richter scale magnitude, what it actually is telling us is, if we use the log scale that I talked about earlier, what it's referring to is that log scale. So an 8.9 on the Richter scale is 31 times more intense than a 7.4 on the Richter scale. All right, one more earthquake problem. We got another Richter scale problem. It's the same equation from that previous problem. It's not actually, the equation is not actually given in this problem, but it's the same equation. The 1906 San Francisco earthquake had a magnitude of 8.3 on the Richter scale. At the same time in South America was an earthquake with a magnitude of 5.3, which only caused minor damage because small earthquake. How many times more intense was the San Francisco earthquake? Okay, well, that question, how many times more intense, is referring to this ratio, right? So that is, again, our answer is just the ratio of I over I sub 0. And we don't need to know what I is. We don't need to know what I sub 0 is. We just want the ratio that compares them. So take the two Richter scale numbers, 8.3, 5.3, subtract them to find the difference. In this case, it's just 3. 3 is the R number in my equation, so 3 equals log of that ratio. To get the ratio, we just need to do the inverse of the log. So raise everything up as a power of 10. 10 to the power of 3 is the ratio. And if we calculate 10 to the power of 3, that is 1,000. Okay, this one is the final answer, the end. 1,000 times more intense. Okay, this one's a little bit easier to visualize from that log scale from earlier. It's like 3 on your volume knob. On the scale, the log scale, it's 10 to the power of 3 is 1,000, right? So that's what this is looking like with easier to understand numbers. It's just straight up powers of 10. Final answer. All right. Have fun. Good luck.